Welcome to EDU World Space.
In this multi-part question, we're asked to draw the Lewis structure for the ligand shown. Now, I don't have the drawing shown here, but I do have the elements included. And so a Lewis dot structure shows the bonding between atoms in a way that the figure shown just can't. Specifically, how those elements are bonded together and the lone pairs of electrons that may exist in the molecule. So when we look at this sequence of elements here in the figure, we can start to draw out the Lewis structure as starting with this nitrogen here. So we'll start out, let's do writing, that would help, with the nitrogen bound to two hydrogens. We're going to put those above and below, and then show the lone pairs here on the left. Just for ease, you could have swapped this hydrogen to be here and the lone pairs to be up here. It doesn't really matter there. And then this nitrogen is going to be bound to this next CH2 that's right here. So we're going to show that going to a carbon, and again a hydrogen, and second hydrogen. This third CH2, draw C, then an H, second H, and these bound. Next is going to be an NH, so we're going to draw this nitrogen with one hydrogen, and this nitrogen is going to have a lone pair on it. This goes into a CH2, which again is CH. Now, the reason why this nitrogen has a lone pair on it is because it's making 3 bonds, meaning that it has an electron pair based on where it is on the periodic table. The same for all of these carbons, which have 4 bonds. After this CH2, we go into our CO2, which is going to be another carbon, and then an oxygen, and another oxygen. Now, because carbon always forms 4 bonds, one of these oxygens is going to have a double bond. This oxygen is going to have 2 lone pairs in order to create the 8 electrons needed for this oxygen atom. So we've got 2 in this bond, 2 in this bond, and then so total 4, 5, 6, 7, 8. And then for this oxygen, we'll have 1, 2, 3, 4, 5, 6, and then 7, 8 in this bond. Now that gives this oxygen a negative charge, giving this whole molecule the negative charge. So this is going to be your Lewis dot structure. Now, part A of this question asks which atoms can serve as donor atoms. And a donor atom is going to be one that has an electron pair with which to donate as a ligand. And those are going to be your nitrogen and oxygen atoms. It then asks whether this ligand, or to classify this ligand as monodentate, bidentate, or polydentate. Now, you could imagine a couple of different ways that this molecule could become a ligand. Its ability to donate electrons from this nitrogen, from this nitrogen, from this oxygen, from this oxygen. Now, realistically, you're probably going to have electrons being donated from this nitrogen and from this oxygen, or from this oxygen and this nitrogen, just based on the sterics of how this molecule exists, which you can see in the figure provided in the question. they're not necessarily going to bend around so that this oxygen, this nitrogen, and this nitrogen can all bind to the same, or can bind to different sites on the metal complex. And so this molecule is likely to be a bidentate ligand. By that, we can answer part B, which asks how many of these ligands are needed to fill the coordination sphere in an octahedral complex. An octahedral complex is one that has 8 sides, and so it has, or 8 faces, and so it has 6 binding sites for a ligand. So if our molecule is bidentate and it has 6 binding sites, that means that we will need 3 of this ligand in order to bind to an octahedral complex.